yesterday we finished the methods for pre-screening the sites, selecting the sites. Once you select the sites, if you still have to do more investigation to know the problem, to come up with the solution, then you have to prepare two types of diagrams. We call it collision diagram and condition diagram. Okay, collision diagram shows you different types of crashes, how they happened, where they happened, who was involved, what conditions, date, time, weather, surface conditions, so on and so forth. Okay, from that you try to identify clusters. Clusters meaning something which has common features. So what are the most common features in these accidents? Okay, maybe all of them were related to pedestrians, or all of them were related to trucks. Okay, so try to find out the common features. Once you find the common features, now you can move towards selecting a countermeasure. Countermeasure means a solution for this site. Okay, what can I do to reduce the crashes on this site? Okay, that is called as a countermeasure. We discussed some points here. Moving on. So the last point was that once you have selected the countermeasure, you have to be careful that this countermeasure may start some other issues on the site, okay, which are not there right now. So there are two examples. For example, the analyst may be asked to install a traffic signal or a guardrail, okay, because they found there is a problem on the site, and if you do one of these things, it will solve the problem. If you install a new signal or you put a guardrail, then it will solve the problem according to their opinion. These solutions are coming from judgment and experience. There is no equation that I will put this and the equation, I will find out the solution. Okay, so so these countermeasures can come with their own risks. Okay, so for example, installing a new signal may have crashes which are rear end. It may start more crashes which are rear end. Okay, or it may impact the traffic flow. It may make the traffic flow slower, or have more delay in traffic. Okay, and the guardrail, maybe it will increase the severity of the crash. So earlier there was a problem that the car is going outside towards the shoulder. Now with the guardrail, the car may go and hit the shoulder. May go and hit the guardrail. Okay, so the collision which was less severe earlier, now it can become more severe because of the change you have made. Okay, so you may reduce some of the crashes, but you may increase something else. Okay, as an example, you update signal timing at an intersection without looking at the other intersections. So somebody came and said, okay, we have a problem with the signal timing, change the signal timing. Okay, but that signal was part of a coordinated network. Okay, something we discussed earlier. The bandwidth and okay. So if you have coordinated signals, the requirement is all signals must have the same cycle length. Okay, so somebody came and said, we have a problem with this intersection, let us change the cycle length or signal timing. Now it will break the whole network. Okay, so these things can happen. Okay, when you are considering fixed objects, when the problem is with a fixed object like a light pole or a signal post, something like this. Okay, you can consider some of these actions, okay, as countermeasure. Is it possible to remove the object? So there's a light pole which is creating the problem. There's a tree which is creating the problem. Is it possible to remove the object? Okay, first option. Second option is, okay, I cannot remove it. Remove it, I will take it somewhere else. Like, it will not be on the site. Gone. Move it from the current position to somewhere else. Okay, so the tree was okay. The light pole was 10 feet away from the road. Now I make it 20 feet away from the road. Okay, so moving it means moving it to some other place on the same site. Okay, the next option is, can I make it safer? Okay, so you see a car hitting the pole or this pole, whatever. will be more dangerous than a car hitting this barrier. Yes, hitting the pole will be more dangerous as compared to just hitting this barrier. Okay, this is called as the breakaway support. Okay, so you put something in front of the object which will come in contact with the car first. Okay, so the impact will be to that thing which you have put in between them, not the actual object. Okay, so in order to save the impact to the real object, we put some smaller object which will take care of the collision. Okay, so the collision will happen to this, not to the pole. Okay, then the last option is you shield the object. Shielding means you protect it from all sides. Okay, so there is no impact going towards an object. Okay, so you may have, for example, it's not shown here, but you may have like a pedestrian bridge. Okay, so you have pedestrians coming down from the bridge. Okay, and the stairs are right beside the road. Okay, so you may put a guardrail between the stairs and the road. Okay, that will completely shield it. Okay, shield means that it will not even go towards that side now. It's completely blocked. Okay, so make it safer means it will still take the impact. Okay, so what will happen? This thing will reduce the impact. It will not stop the car. Okay, but the impact will be less on the pole. Got it? So the difference between these two is this will completely block the car. This will reduce the speed of the car, you can say. Okay, or the impact of the car. Clear?
To save the signal, not to save the people.
Obviously, signal is. Okay. In my other course, I don't know. I think none of you have taken it with me. The report writing and presentation and that type of course. So I asked them to, maybe some of you have done it, 1 minute introduction. Okay, so one of them came and said, "Doctor, I'm not prepared." So I said, "It's your introduction, only 1 minute. What preparation you need? Just do it." Okay, so I can give you the number. He said, I cannot do it. I said, "You cannot even think something about you which is worth 1 minute?" He said, "No." Value of human life. He cannot talk about himself in 1 minute. See? So what will
They
you
think
do?
you talk about me.
Huh?
They think I'm that
No.
guy. Not that guy.
No. He can talk for 1 hour. You can talk for 1 hour. Okay. Yes. Now, from where do we get these countermeasures? Okay. Now we are selecting the solution for the problem. We identified the problem. From where do we get the options? Okay. How to solve this problem? Okay. There's a website. Okay. This will not work now because internet very slow. But if you click on this link in the slides, okay, it will take you to a website, and that website is a database. Okay. In that database, you can type what type of site you have, what type of location you have. For example, we have a 4-lane freeway, or 2-lane highway with median, 2-lane highway without median, signalized intersection with 4 approaches, signalized intersection with 3 approaches. Okay. So what it will do, it will list down all the data related to that site for countermeasures for these type of sites, which others have done and studied. Okay, so you are doing it for a signalized intersection, okay, and you are looking for solutions to reduce the accidents. Okay, so whoever did something related to signalized intersections, okay, and it could be 3 leg, 4 leg, anything. Okay, you can be more specific. Okay, you can be general. I need for any intersection, or I need for signalized with 3 leg. You can put more details. It will give you more specific answers. Okay, so it will list down all the solutions which anybody applied somewhere and how did it work. Okay, so it will show you solution. First solution, increase the height of the signal pole. okay, and who did it, and what was the result in terms of accidents. Okay, so it was done in some city in Pakistan, it was done in Saudi Arabia, so on and so forth. It will give you the list. Okay, when it was done in Pakistan, the crash is reduced by 10%. It was done in Saudi Arabia, the crash is reduced by 5%. Okay, so you know what is the solution, where it has been done, and when it was done, what was the result. Okay, and like I already mentioned in the previous slide, in some cases, it may have some other effects which will increase the crashes. So if it was like something like this, it is also reported. Okay, so this one is a database where you can go and digitally search for a solution for your site. But you should know the type of site you have. Okay, and then you can look for the solution. You can even search for a specific type of crash. So right angle crashes on 4-leg signalized intersection. So it will only give you the solution for right angle crashes on these sites. Okay, you can have a look at it. Apart from there are some solutions given in the books as well. Okay, so this is from the book, and there's a manual as well which has these solutions. So in the book, it is given according to the cause, the reason of the crash, and then the solution. Okay, so if the reason is sight distance, then what can be the possible solutions? Remove obstructions. What is obstructing the sight distance? Put a warning sign, an extra warning sign. Okay, this is why you see on some of the signals, before the signal you see a sign, signal after 200 meters, okay, or around about 200 meters. So this is the warning sign they are talking about. Okay, or the third one is they reduce the speed limit. Okay, so 3 possible solutions. The problem is with the sight distance, and so on and so forth. Okay, so this is, and the good thing is again, this is for right angle crashes. Okay, so you are studying right angle crashes, you found the problem is with sight distance, then you can do one of these things. You found the problem is the crash is right angle, and the problem is speed, then do one of these things. Okay, so this entire thing is for the right angle, and this entire thing is for the rear end. Okay, now you can see the type of sight is not mentioned, whether it is for an intersection or highway or a street, it's not mentioned. Okay, but some of these crashes can only happen at a specific site. For example, right angle. Okay, you don't expect this one to happen on a highway. Okay, it will be on the intersection. Okay, any type of intersection, and then you can choose one of the options depending upon which one is applicable on your site. Okay, so for example, if you go here, which one is more applicable on your site? Can you do this? If it is intersection, there is no point of reducing the speed, right? It's already an intersection. Okay, then you will look for other options. Okay, so you can pick an option which is relevant to your site. So this is a list which is given. You can go through it, but it depends upon the type of crash you have and the cause of the crash. So you must know these 2 things. Okay, and from where do we get these 2 things? This comes from here, these 2 diagrams, the condition diagram and the collision diagram. The collision diagram will tell you what type of crashes are more important. Okay, what type of crash is happening in higher number. Okay, and this one and the condition diagram can tell you what is the problem, why they are happening, what is the reason. Okay, so you have to study these diagrams to come up with the information required for selecting a countermeasure. Okay, so we have a 2-lane rural highway. It has run off the road crashes. Okay, so car keeps on going off the road for some reason. Okay, I don't know. Okay, so they have seen there are how many? 2 run off the road crashes in the last 3 months. 2 in 3 months is considered long. Okay, because 2 happened. That means there were others which were not recorded. Maybe they didn't happen, but the driver did the same thing. He went off the road and so on. Okay, the posted speed limit is 55 miles per hour, and after investigation, they found the reason is these 2: excessive speed and slippery pavement. Makes sense, right? You're going at high speed and the pavement is slippery, then there's a chance that your vehicle may go out of control. Okay. The possible countermeasures are these. There are 4 possible countermeasures. Okay. Put a new asphalt pavement. So reduce the speed limit. Install a guardrail on the side so they will not go off the road. Okay. And provide adequate drainage to have the water out of the way. Okay. Because the wet pavement means there is water on the pavement. That's why it's wet. Okay. So maybe there's a problem of drainage there. Okay. So yeah. Which one? This one, right? Run off the roads. Okay. So we are looking at this situation, and we are looking at these two. Okay. So we have this option available, reducing the speed limit. This option is available. Okay. Reducing the speed limit, same thing. Overlay pavement, this option is available. Okay. Provide adequate drainage, this option is available. Okay. So these 3 options are available. Okay. Groove pavement and provide slippery when wet signs. Okay. So this is for increasing the friction of the pavement. Okay. So they make some extra, you can say like holes. Okay. They are not holes, but something like which can provide more grip to the car, to the tires. Okay. And this is like a warning sign. Put a warning sign there. Okay. So out of these, they are considering these 3, right? Okay. And out of these 3, you can see that this one is common in both of them. Okay. So this is how you can rate which options are available and which one will be more suitable. So you already identified there are 2 reasons, and this one is common for both of them. So maybe you go for that one. Okay, but you can see in no case this option was mentioned. So this will be cancelled out. Okay, according to that list. Okay, we have rural 4-leg 2-way stop control intersection across the state, which have been screened and so on. They are considering that we will replace the stop control with the roundabouts. Okay, so as a safety analyst, you have been asked to make recommendations for the effectiveness of this treatment. So they have identified their safety problems on stop control intersections. They said, okay, we remove the stop signs, put a roundabout there. So what will be your suggestion to them? Okay. Now I already mentioned the website link, right? Okay. So if you go there, you will find something like this. So I already made my search. Okay. For 4-leg intersection, converting them from stop to roundabout. Okay, and this is the result I got. Okay, so you can see how many studies there are at that time. Obviously, it may have increased now. So how many studies have done this measure? 6 of them. Okay, this gives you quality of the study, not the measure. The quality of the study. Okay, so a 5-star study means it's very authentic. Okay, the results are more reliable than other studies. Okay, so you have 4 stars and 3 stars and so on. Okay, what was the result in these studies? So here this says crash reduction factor. Crash reduction factor. Okay, so in 1, 2, 3, 4, 5 of the studies, there was a reduction in crash because of this. And how much you can see? Okay, and one of these studies there was an increase. Okay, and how much increase? This one. Okay, and if you want to see why this happened, how this happened, you can click on this. It will take you to the study and you can see the reasons and so on. Clear? Okay, so this is how we use that website. Okay, so most of the results are favorable. Okay, they are going positive towards the installation of the roundabouts. And I already mentioned this in the topic when we were discussing the roundabout. Okay, one of the biggest benefit of the roundabout is the safety. Okay. Okay. So once you have selected the countermeasure, you will apply it. Then you have to do a before and after study. Okay. And the before and after study can be for accidents, or it can be for conflicts as well. Okay, so you can compare the accidents, crashes before and after, or you can do a before and after conflict study. Okay, conflict means what? What is the difference between conflict and crash, accident? It happened. Okay, conflict almost happened. Very good. Huh?
Crash at the same time, two cars touch at one point at the same time.
If they have crashed, then it's a crash. Okay. Conflict, there was no crash. They came almost to the point of crash, but one of them stopped or changed the lane or something. Okay. So conflict is anything which you did to avoid the crash. Hard braking, changing the lane, whatever. Okay. Anything to avoid the crash is a conflict. Okay. So before and after study can be one of these things. When you are doing before and after studies, you may face one of these problems. Okay. The first problem is before data is available for a long time, because the highway was open for 10 years now. So you have the before data for 10 years. You just made the change now. Should I wait for 10 years? No. Okay. So we have to accommodate the difference in time. Second problem is difference in exposure. When you made changes on the site, it may change the volume as well. Okay. So now the traffic has changed. There's something, even if you wait, this is not in your control. Okay. Something which happened because of the change, or just in any case. So this happens by default, right? Even if I don't make the change, the traffic of one area is not the same as the other area. Okay. So this happens default as well. Accounting for unexpected events, which is not related to the change you have made, but something happened in general. There was a new mall built in that area. Okay, or there was some event in that area. Okay, so that event or that mall or that thing will have an effect on the volume and so on, and the crashes as well. Okay, so again, something which is not in your control. And accounting for regression to mean. Okay. I will talk about it later on. So first of all, accounting for difference in time. If there's a difference in time, what should I do? For example, you have the before data available for 45 months, and the after data is available for only 15 months. Okay, so how can you compare between them? You cannot compare 45-month period, 45-month period with 15-month period, right? So you have to adjust what? The after. The after data should be increased. Okay, so what do? We take this ratio, which is before, the time before upon time after, and multiply the ratio with the number you have. Okay, so before data was 45 months, whatever number I have. After data is only 15 months. So 45 upon 15 gives you 3. Okay, so every after value will be multiplied by 3. Okay, so now whatever the number I have, I can now compare them. The second problem was exposure, the difference in what? Volume. Okay, you do the same thing. Volume before, volume after, and you get the ratio, the number after should be multiplied with this ratio. Clear? Okay? Any problem? Okay. Next one was accounting for any unexpected event. Something which is not related to the site. Okay? Something which is not related to the data or the change or the site itself. Something which happened in general, okay, in the environment or whatever. Then we compare the sites with similar sites. Okay, so it was, for example, an event, then it will impact all the similar sites, right? If it was because of weather condition, maybe in those 1 month there was heavy rains. So it will have an impact on all the similar sites, right? You compare the data of your site to the similar sites, and you see if there was a sudden drop or sudden increase in these sites or not. So if all the sites are showing, for example, a sudden increase in the crash, then it's not because of something you did at the site. It's something which happened everywhere. Clear? Okay. So comparison with the sites and yeah, and you can compare with the, you should compare with the sites which do not have your countermeasure. Okay. Okay, the last one is regression to the mean. Okay, this is when you calculate an average. When you calculate an average for a set of numbers. Okay, so if the average is 5, that means what? Some numbers were more than 5 and some numbers were less than 5, right? Okay, so 5 is their normal value, but it doesn't mean that all numbers were 5. It means what? There was some variation. Okay, so there, and we have used it in one of the previous methods as well. If you are too close to the average, okay, we consider it normal. Okay, average is 5, and one is 5.1, 5.2, 5.3, still normal, huh? Same thing, 4.5, 4.6, 4.7, normal. Okay, it's considered normal. Okay, so regression to the mean is how far from the normal you are going. Okay, how far from the normal you are going. Okay, and so you are supposed to go up in some cases and you are supposed to go down in some cases. This is normal. To have this much average, some numbers must be above this, some numbers must be below this. Okay, why they are going up and down? Random. Okay, you cannot have temperature same every day. You cannot have wind velocity same every day. If you take the grades, you cannot have the exact same grade in all the courses, right?
Sometimes happen.
Huh? Not ABC. The grade, the number.
Or 16.
Okay. Okay. So the exact same number. Okay, this is not possible for any real world data. Okay, so if the data is collected for anything which is happening practically on the site, open data, okay, some numbers are supposed to go up and some numbers are supposed to go down. This is how you get the average. Okay, this is why you get the average. All numbers were equal, you don't need the average, right? Okay, and even if you buy anything, okay, so they give you a margin, right? That this thing, the speed of this is this plus minus this much. Okay, because in the real world, this cannot give the same value every time. It's not possible. Even if if something is made in a factory. Okay, random error. Okay, so this is basically the regression to the mean. So you had some data before. Okay, you calculate an average. Then you saw the data after. The average was 5. Now the after is 7. You say it's an increase. Okay, there's an increase. There's an increase, right? Okay, but maybe the increase is just random variation in the data. If you wait for another day, it may become 4. Okay, because even that 5, that average of 5 before, it was not 5 exactly every year. Sometimes it was more than 5, sometimes it was less than 5. Okay, so maybe if you wait for a long time, this will happen after as well. Okay, so this is called as regression to the mean. Okay, some values are going above the mean and below the mean. You just need to have the actual mean. Okay, so this can be a problem that somebody looks at the data for 1 year and he says the number of crashes have increased or decreased, but he doesn't know the average. So what is looking as increase or decrease to him may be normal. Okay, if he waits for 3-4 years, he gets the average, maybe he will get the same average. Okay, that's why we mentioned at the start that we do not consider crash data for small periods of time, because it could be 0 or 1. Okay, so we don't have crashes per day, per week, so always in years. Okay, because of this problem. Okay, so you may overestimate your countermeasure. In many cases, what happens? You increase the lane. Okay, so you increase the lane. Now the drivers are becoming more, because now it's something new. So maybe they are more careful. So now you see a decrease in the crashes. Okay, but it's random. Next month drivers will be more used to it, they will go back to their same old habits and you will see the same accidents. Okay, so you have to be careful about that. And there are equations which we use to calculate the actual impact of a countermeasure. These equations are called as safety performance functions. Okay, what is a safety performance function? It gives you the number of crashes expected to reduce because of a countermeasure, because of a solution. Okay, so this can, according to the book, and obviously they have done their own experiments, this takes care of this issue as well, regression to the mean, because now you are calculating the number which is expected. Okay, so this takes care of it. There is a manual which is called as Highway Safety Manual. Most of the things which I have taken, in fact all the things are there in the manual. It has some extra information as well. So it's available online, free, and you can download it. So they follow a procedure to predict the crashes for any new site, with the countermeasure, without the countermeasure. So if you are designing a new road, you can follow this method to predict how many crashes are expected. Okay. So first of all, it starts with which sites you want to apply this method to. Okay. So pre-screening of the sites, selection of the sites. Then the site you have selected, the site which you have selected, find out other sites which are similar to it. Okay. And for all these sites, collect the crash data and the volume data. Okay, so first step is select the site on which you want to apply the method. Second is find out all similar sites in the same area and collect for all of them, your site and the other site, the crash data and the volume data if it is available. Then you apply the, what is this? Safety performance function. Okay, so you apply the safety performance function for your site and calculate how many crashes are expected on your site. Okay, so in that calculation you need the other site's data as well. It's already incorporated. And yes, in their method they have crash modification factor as well. Okay, so you say there's a site which has a roundabout and 4 directions. Okay, but in their data they have an equation to calculate the number of crashes for a site which doesn't have a right turn median, a right turn island. Now in your data you have a site which has a right turning island. When they were making the equation, they did not consider the right turning island. So the function gives you number of crashes without the island. Okay, but then you have crash modification factors. Remember this which I showed you. This is called the crash modification factor. The reduction in crash or the increase in crash because of the change you have made. So again, let's say your change is applying the right turning island, traffic island. Okay. So the equation, the function gives you the value without the island. Then you apply adjustment factor for the island. Okay, which is called as the crash modification factor. Okay, the percentage of crashes which are expected to reduce because of the island. So you get a value which is base. Okay, your benchmark. Then you apply the modification factor because of the change you have. Okay, and then we have another factor which is called as the calibration factor. Calibration factor is for the difference in area. So this function was developed for US. Now I'm trying to apply it for Bahrain. So there must be some adjustment factor for the Bahrain conditions as well. Okay. So this is for the change in condition of the site. This is for the change in condition of the area. Okay. So this gives you the base value. Then you apply the adjustment factor, whichever is applicable. Okay. So then you will get the number of crashes. You can apply it to a project, one site, or you can apply it to the entire network. Okay. And then so if you want to apply it to the entire network, you will repeat the same process, all these steps for every site. Okay, and then you can combine and compare and so on and so forth. Clear? Okay. Any questions? Okay, I'm stopping here. We will start the new topic next time.